Chapter 10, Part 2, Resistance Training. Chapter 10, Part 2, Resistance Training, page 341, Muscle Fiber Adaptations and Resistance Training. Muscles will have a varying degree of type 1 and type 2 muscle fiber size, depending on their roles. Typically, the prime movers, such as the vastus lateralis muscle, contain more of the powerful type 2 fibers, while the postural muscles, such as muscles of the abdominal wall, contain more type 1 muscle fibers. Additionally, people differ in the total ratio of slow to fast twitch muscle fibers they possess, depending upon their genetics, as well as their choice of sports or activities and activity level. Typically, sedentary children and adults have fewer slow twitch fibers than elite athletes. Although athletes will see adaptation with training, the upper limit of adaptation is governed by the individual's muscle fiber number, type, and size. While studies have shown mixed results, generally muscle fibers can transition to faster type 2 fibers through power training. This could be due to the fact that training-induced transitions in fiber type may be muscle-specific. Just as in strength training, power training has the potential to increase muscle size or hypertrophy. In terms of force in the contraction velocity of the specific muscles, the preferential hypertrophy of fast twitch type 2 muscle fibers is a critical factor. Because they are more fatigue resistant, the fast twitch fibers that typically develop from training are the type 2A, not the faster and stronger type 2X, which actually can be repressed through heavy training. In fact, a period of detraining may lead to increases in the proportion of the faster type 2X fibers. This provides a great rationale for the tapering of heavy training with lighter, lower intensity exercises prior to competition for high levels power athletes. General adaptation syndrome. General adaptation syndrome. The human movement system seeks to maintain a state of physiological balance or homeostasis. To do this, the body must be able to adapt to stresses placed upon it. Adaptation to stress follows a predictable pattern commonly called the general adaptation syndrome. In order to respond, however, the body must be confronted with a stressor that creates the need for a response. There are 3 stages of response to stress: alarm reaction, resistance development, and exhaustion. Those are the 3 stages of stress. Alarm reaction. This is the initial reaction to a stressor. It allows for the activation of protective processes within the body. For example, an athlete begins resistance training and places the body under the stress of increased amounts of force on the bones, joints, muscles, connective tissue, and nervous system. This creates a need for increased oxygen and blood supply to the right areas of the body, as well as an increased neural recruitment to the muscles. Initially, the athlete's body is very inefficient at responding to the demands placed upon it. Thus, it must increase its ability to meet these new demands. Consider the typical response to either unaccustomed exercise or a sudden increase in a training program. The new work is performed, and over the next 2 to 3 days, the muscles may exhibit classic delayed onset muscle soreness. During this period of DOMS, any attempt at replacing or advancing the soreness-inducing exercises will be limited by the factors contributing to the soreness. This could be considered an alarm reaction. Resistance development. During the resistance development stage, the body increases its functional capacity as it adapts to the stressors. After repeated training sessions, the human movement system will increase its capability to efficiently recruit muscle fibers and distribute oxygen and blood to the proper areas in the body. Once adaptation occurs, the body will require further stress to produce a new response and a higher level of performance. Manipulating the amount of weight the athlete uses is only one way to increase stress on the body. In the example of unaccustomed exercise, once DOM subsides, intensity may gradually advance. This would be resistance development. Performance will continue to improve until a new stimulus is reached and will be maintained if training is maintained. Performance will continue to improve until a new stimulus is reached and will be maintained if training is maintained. Exhaustion. Exhaustion. Prolonged stress or stress that is intolerable to an athlete will produce exhaustion or distress. Too much stress placed on the system can lead to performance detriments because of injury or staleness. The athlete in this exhaustion stage can suffer from a variety of issues that can reduce performance, such as stress fractures, muscle strains, joint and muscle pain, emotional fatigue, stress fractures, muscle strains, joint and muscle pain, emotional fatigue. Resistance training and any other form of training must be cycled through different stages that increase stress placed on the human movement system and also allow for sufficient rest and recuperation. Back to the example of a new or unaccustomed exercise. There may be a point where further advancement in a training program fails to lead to an improvement in performance, and actual performance may decline. This would be the exhaustion stage. A continued increase in resistance with the intent of stressing the muscles of the body to produce a size or strength change can lead to injury of the muscle, joint, or connective tissue. Connective tissues such as bone, ligament, and tendons do not adapt as quickly as muscles due to their individual nature and the lack of blood supply, or some tissue like cartilage and tendon. The different tissue in the body, muscle, connective, epithelial, and nervous, each have a different potential to adapt to stress. This means training programs should provide a variety of intensities and stress to optimize the adaptation of each tissue for the best possible results. Adaptations result from the specific application of stresses to specific aspects of the human movement system using different training techniques. This is evident by the said principle. Periodization, division of a training program into smaller progressive stages. That's a